Hello everyone. So today we'll be going through the problems of Codeforces round 932 division 2. I was able to solve till problem D, so we'll be going through the first four problems. Okay, problem 1. Congratulations, you have been accepted to the Master's Assistance Center. However, you were extremely poor, whatever. You're given a string S and an even integer n. Okay. There are two types of operations that you can apply to it. Okay, we can apply either of these two operations. We reverse the string, add the reverse string to the end of the string. Okay, so we have an S string, we keep it over here, we reverse the string and we concatenate. So that is one operation that we can do, or we can just reverse the string. That's it. It is required to determine the lexicographically smallest string that can be obtained after applying exactly n operations. Okay, note that we can apply operations of any type in any order. Okay, and a lexicographically smaller string would be whoever's prefix is whoever is the prefix of the other. In the first position where A and B differ, the string A has a letter that appears earlier in the alphabet than the corresponding letter in B. Okay, so that is pretty straightforward. And one thing to notice is that because n is up till 10 to the power of 9, and as you guys know, a lot of you would be knowing that the maximum number of operations that we can do in a contest is in general around 10 to the power of 7 to 10 to the power of 8, so we can't do an order of n operation over here. And so basically we can't be doing reverse and concatenate and all this for the whole string. So that is one of the clue to understand that okay, we won't need to do n number of operations, right? So that is a first kind of a intuition that I got. So I just thought that because n starts from 2, right? So I just thought that maybe the maximum number of operations that we would require actually is 2 to get an optimal answer. Okay, so that was the intuition. I want to tell you, everyone, the way I approached the problem and how I built up to the solution. Okay, so let's just see an example. So over here it is CPM, right? So the first letter is smaller than so basically CPM is, let's just go over here. Okay, CPM, if we reverse it, it becomes MPC, right? So which one is smaller? This one is lexicographically smaller, right? So we will just keep this one, right? So and n is always even, right? So one thing to notice is that if the original string is lexicographically smaller than the reverse string, the answer will straight away be this, right? If the reverse string, so for example in this case, let's say in this case the reverse string is small, the reverse string would be ARABYPAC. So the reverse string is smaller, lexicographically smaller than the original string. So in this case, this would sorry, this would be the answer. But the problem is that the number of operations that you can do is always even, so you can't just reverse it in operation one, in one operation, and then just output the answer. You must use at least 2, 4, 6, 8 even number of operations. So in that case, what do you do? So in that case, we have, I just got the intuition that we have two options basically. We concatenate reverse of original, reverse of original. This is one thing that we can do. So that will take two operations. Or what we can do is we reverse it first. So we got this, and then concatenate reverse of reverse, right? So we reverse it, one operation, and then we just concatenate the reverse of reverse, this value. Okay, so whichever this or this, whichever one gives a lexicographically smaller string, we output that. So that will be our answer. So let's go to the code and see the solution. We take our strings, and then I'm just copying the same string to the to s2. I reverse the string to, if s1 is less than equal to s2, if s1 and this less than equal to for strings is basically lexicographically smaller. So if s1 is lexicographically smaller than or equal to s2, just s1 is our answer. Else I create the two strings. The first string is original string plus reverse concatenating the reverse string. The second string is reverse string and concatenating the original string, right? Because reverse of reverse is basically original, right? So basically original plus reverse or reverse plus original, these are the two options. So if s3 is less than s4, s5 is equal to s3, else s5 is equal to s4, and s5 is basically the final answer, and I just output the final answer. So that was problem A. Let's go to problem B. Okay, so problem B was the level of clarity with which I solved problem B was really amazing. So in this one, we are given a homework assignment. Okay, there is an array of length n, and we want to divide this array into k subsegments. Okay, k subsegments, and k should be at least 2, in such a way that the max on each subsegment is equal to some same integer x. Okay, so what does max means? Max means the minimum value which is not present in that subsegment, minimum positive integer that is not present in the subsegment. So for this one, 2221, 0 is not present, and it starts with 0, right? In this one, 0 is present, 1 is present, 2 is not present, so 2 will be the max. In this one, 0 is present, 1 is present, 2 is present, 3 is present, so 4 will be the max of this one. Okay, and then so basically let's go over here. Okay, so in this one, we have to divide the whole segment into k parts, right? And we can choose k anything, right? So we can divide it like this, or like this in just two parts, or like this in eight parts, something like that. So one thing to notice, and this is an intuition that I got after just doing the just trying to finding the max 0. So what will be the max starting from here till here? 1, then it will be 2, 2, 2, 2, 2, 2, 2. And I realized something. What I realized was, let's say the max from here to here is 2, and the max from here to here is 2. If the max of both of these are 2, what will be the max of this? It will be 2 as well, right? Whatever the maximum of these two would be, the max of the combined will be the maximum of the smaller ones, right? And all the values, all these subsegments max should be equal, right? Right. So I thought so let's say we have this situation over here, that we have, we are dividing it into three parts. In that case, we can just combine any of these two. So let's combine these two. It becomes this, right? The max will be still 2, right? So the intuition that came was, we can always assume that we only need to divide the whole array into two parts. That's it. And we just need to equal them. We need to divide the array in such a place that the max of the two subsegments is equal. We just have to find a partition, one partition, such that the two parts that are created has the equal mix. That's it. Okay, 1 2 3. Okay, so that makes our work a lot easier. We just have to loop once. So what we can do is, we can just loop once from this side and just see the max, and we can loop this side and just see the max. So from over here, the max will be 0, 1, 2, 2, 2, 2, and 2. So we just need to check which position is giving equal max on both the sides. Over here, if we partition, the max on of this side is 0, of this side is 2. So this is not it. Let's go over here. The max over here is 1, the max over here is 2, and this max is basically giving the max of this is giving the max of this, right? So that is this, so this is not equal, so that is the problem. Let's go to the next one. Over here, the max over here till over here is 2, the max from over to over here is 2, so this is equal, so we can partition over here, right? So that's it. This index is basically our answer. So what we need to output is just 2 and 1 till whatever index we partition, and index plus 1 comma n. Yeah, so this will be the two subsegments, right? So that is the solution. Let's go to the solution. I don't know why the solution looks so elongated. Anyways, so we take the input in our vector, and then I'll just wait. I'll just wait. Yeah, and then I create a pre and a post array in which we'll be storing our mixes. I insert, wait, I have a, oh, okay, so now we need to uh, how do we find the max at any position, right? So what I do is I create two sets, and I insert every value from basically every positive value from 0 to n in both of these sets. Okay, and every time I go to a particular position, I just erase this particular value from my set. So whatever value is at the start of the set, and set stores all the values as unique values and in ordered style, in an ascending order. So whichever value I land upon, I just cross that from the set. So when I go to 1, I'll just cross 1. When I go to 7, I'll just cross 7, and whatever value will be in the start of the set will always give me the max, right? So let's say just a second. So let's say S1 has 0, 1, 2, 3, 4, 5, 6, 7, and 8, right? Because n is 8. Okay, and number of elements can't be more than 8, so that this is good enough. And then what we do is, moment we land upon 0, we remove 0. So the beginning element gives me the max 1. The moment we go on 1, we remove 1. The beginning element gives me the max 2. The moment we go on the next one, we remove 7. The beginning element gives me the max. Then we go on 1. 1 does not exist. We can't erase 1. Okay. The next element is 0. 0 is not there. We can't remove. So the beginning element is 2, and so on. So this helps in finding us the max. So this is what that is. And then I initialize my pre and post with -1, and then I just loop through 0 to n minus 1, and I erase one by one whatever value we stored in the vector, and pre of I will be the value at the beginning of the set 1. And then I do the same. Repo is basically loop from backwards from n minus 1 till 0. In I just remove the value from s2, and then I just add that value, the beginning value, the max, to post of I. Okay, so I'm maintaining this vector now. Then we just initialize our index with -1, because the answer might be -1, that we don't find any partition so that the maxes of the two subsegments is equal. So it might be -1, so we initialize it with -1, and then we go from 0 to n minus 2. The moment we are checking this value and this value, right? If we want to partition it over here, we'll be checking this value and this value. So that is what we do. We check pre of I and post of I plus 1. If both of them are equal, we have found our index. We just can just break the loop. And if index is equal to -1, we don't find any of the partitions, we output -1. Else we output 2, because there are two subsegments, 1 and index plus 1, index plus 2, and n. Because this is index plus 1 and index plus 2 just because the indexing that we were using was a zero based index. So that was B. Let's go to C. Okay, So in problem C, I'll just explain you the problem myself. I'm assuming that you have read the problem. Okay, so we are given this, right? By the way, I have this already made because when I'm solving the problem myself, I solve it on Microsoft Whiteboard, so it's easier for me. So we are given two values in problem C, n, and uh, this is L. Okay, and then these values are A. This is an array of A, and this is an array of B. Okay, I'll explain to you what all that is. Okay, and we are given this function as well. Okay, so what happens is, and we are given a set K. We are given a set of size K where there are K number of elements, P1, P2, P3, and so on. And we are given a value L, right? We need to find a value. We need to choose these K in such a way that the number of K elements that we have in our set, if we choose those indexes from this array and and put it in a function, which is this function, the value is less than L. Okay, so for example, let's say the three values over here are 2, 3, and 5. So in our k is equal to, let's say, 3, the size of the set is 3, and then these are the three values. Then what will be the output of this function? The output of the function will be 2 plus 3 plus 5, because, sorry, not 2 plus 3 plus 5. Just a second. This is for first, second, third, fourth, and fifth. We'll go to second index, third index, and fifth index, because these are the three indexes that are mentioned in the set. And the value will be 1 plus 2 plus 2, because this part is basically this 1 plus 2 plus 2, because whatever value we have in these indexes from A, we need to add, and then we need to add this minus this modulo, or absolute value of this minus this plus absolute value of this minus this, right? So this is whatever the value that we get. If it is less than L, this particular value 8, then K is a possibility, and we need to find the maximum K, so that we can have a set over here which indexes, if we pick and put in this function, the value is less than L. Sounds really complicated, but, and actually it was complicated because as you can see, way more people have solved problem D than problem C. So it was relatively tougher in general from how the problem C's of code forces are. Anyways, so one thing that we can notice, and I realized it really later, is that it doesn't matter the ordering of these indexes for this part, because it just gets straight up added, right? 1 plus 2 plus 2, 2 plus 1 plus 2, 2 plus 2 plus 1, doesn't matter. The ordering matters for this one, right? So just if we, let's say, take 2 3 5, then it will be 5 minus 4 plus 4 minus 3. So the value is 1 and 1, so that the value is 2. But let's say we do it like 2 5 and 3, 2 5 3, then it will be 5 minus 3, and then um, 3 minus 4. Okay, so this will be 2 and plus 1, so this will be 3. So as you can see, the ordering, because of changing the ordering, the values gets changed, right? So what will be the most optimal ordering for any particular set? So let's say we fix our indexes, then for this particular index, what will be the most optimal ordering of the values. So the most optimal, it is not very hard to come up with this, that if we keep it in ordered fashion, if it is sorted in any way, ascending or descending, then that is the most optimal, right? And based on what shall it be sorted? Based on the values of the b's, it should be ordered, right? Value of this, it should be ordered, not based on this value, right? So if we keep it like, so if we, let's just sort this based on b, so it will become something like 4 3, and then 2 4, and then, sorry, not 2 4, 4 3 4 3, and then 2 3, and then we can take this value 2 4, and then 1 5, right? So this is the ordering now, right, with the smaller b's at first and then the bigger b's. So now if we just, and now let's say our value of k is, let's say 3, just for example, let's say, then we just need to pick three values in some order, and it will be the most optimal order for the values that we have picked. Okay, one thing to realize in this one is the time complexity. The number of n is 2000, and it is for sure that guaranteed the sum of n square over all test cases is not going to exceed 10 power of 6. So we can do an order of n square log n uh, solution. So if we just, let's say, choose a particular, let's iterate for every single um, starting point. Okay, so let's say we choose this as our starting point, then we can maintain a multi set of elements, and we can keep adding elements to this multi-set, right, till the sum of this multi-set is less than L, right? So we are over here, we add 5 plus 3, right? Then we go over here, we add the value plus 4 plus, or wait just a second, 3 won't be added over here, and then plus 3 minus 3, right? By the way, we don't need to calculate sum the second value every single time. Why? Because let's say we start from here and end up till here, the value of 3 minus 3 mod plus 3 minus 3 mod plus 4 minus 3 is what? It is basically, let's say this is R and this is L, it is basically BR minus BL modulo, right? Because all these gets cancelled, right? So we don't need to calculate it for every single one of them. Okay, so it is 4, and then it will be plus 3 minus 3. Okay, then the moment we go to the next one, plus 2 plus, and then this time this will get erased, and we can just add 3 minus 3, this minus this, L, right, R minus L, BR minus BL. Okay, then we will go over here, add 2, and then plus, okay, we can remove this, and we can just add 4 minus 3, BR minus BL. Okay, and we can keep doing this till the sum is less than L. The moment the sum is greater than L, we can do this till the sum is less than L, and we have to find our maximum K as well, right? It should be maximum. We need to have maximum number of elements. So the optimal way to do this, the greedy way, will be to remove the bigger elements if the newer element is smaller, right? So that for that purpose, we maintain a multi-set, we add the values, right? So we add the and then the moment the newer value whatever we get is smaller than the biggest value that we have over here, we just remove the from the back the biggest value out and the smallest value in, or basically a value which is smaller than the last value will be in, so that we maintain it less than equal to L, not equal to, less than L, less than equal to L, and we can have as many Ks as possible while going through all these elements. So this operation of erasing and inserting takes log n, and we'll be doing it starting from every single index, right? For this, starting from here. So that will take order of n into, and after starting from a particular point, we go through the whole array from that point. So that takes n, and erasing and inserting takes log n. So the total time complexity becomes n square log n, right? Big of n square log n. So this was the solution for the third one. Let's go to the code of this. Okay, we maintain a pair of vector, obviously, and we insert our values, and then we sort it, right? And I'm inserting the b in the first position and the a in the second position, so that just when I sort it, the automatic sort in C++ sorts based on the, if the values are a pair, then it sorts based on the first value first and then the second value. So the first value it'll be basically sorted based on b, because b is in the first place. Okay, then we go to our loop. We start from 0 and we go till the last element, and for every single one of them we create a multiset, and then we, till where will we go, what will be the last point, till where will be going. So currently it is L, right? So we start, let's say, from here, and right now we are here, and we'll go till the end, right? And then we'll move this over here, and then we'll again go till end, then we'll move over here, and then we'll again go till end. So right now we are at the 0th index, and the R is also at the current 0th index. And then we start from, we insert the we insert the first value in our multiset. Okay, we add the first value to our current. The second is A, it is not B, it is A, right? You must remember this. Okay, so we added our A while our multiset is not empty, and vr dot first minus vl dot first. So this first is basically B. So the difference, this value, okay, plus the current value. So the sum of A's plus the sum of B's. So the current is this, and this Vr dot first minus VL dot first gives us this, right? Is till it is greater than L, we just keep popping out values from the end, right? And most likely it will be just this loop will go one time, because in most cases, and then we just reduce the maximum value whatever we get, and we just erase that maximum value from our set also. Okay, we do this, and answer will be obviously answer comma the whatever the maximum size of the multiset that we were able to create, and we just return the final answer. So that was C. It was more complex than the usual C's, but they compensated it with the problem D. So the problem D was, I think, easier than how it usually is. Let's just wait for it to. The candidate is given a set of S of size n. Okay, we have a set of size n, so all the elements are distinct, and some strange integer C. Okay, for this set, it is needed to calculate the number of pairs of integer x and y, such that, so we need to find the number of pairs for this particular value C, such that x comma y is less than C. So we need to find two pairs. We need to find a pair of value which is both less than C, and y is greater than x, greater than equal to x. Okay, so x, y, and both of these values should be less than C, where x plus y is not contained in the set, and y minus x is also not contained in the set. So how many pairs can we generate? Okay, so for each test case, n can be up till 10 to the power of 5 and c can be up till 10 to the power of 9. So let's say we have 10 values. Okay, 1 2 3 4 5 6 7 8 9 10. How many pairs can we create, right? So 1 9, 2 8, 3 7, 1496, right? So basically n squared, right? As you can see, if we have n values, it is almost n squared number of values that we can create. And if you use long in C++, the number of values that you can, uh, the maximum value is basically 10 to the power of 18, and over here C is 10 to the power of 9. So then total value that you can create is 10 to the power of 18, right? Because it is n squared. So you can print that in a log, in long basically. So there is no need of modulo. That was just one thing that I noticed at the start, so I'm just mentioning that. Okay, the second line of each test case contains n integers. Okay, and the sum of n over n all test cases is 10 to 5. Okay, okay, so let's just go to the magical whiteboard. mm, yeah, so this is, I did a lot of calculation and a lot of analysis on this one. Okay, so we need to find, okay, so this is our n, this is our c, and we need to find the pairs. Okay, 0 1 1 8, 2 4 pairs like this. Both of them x comma y, basically both of them are less than is equal to c, and y is greater than is equal to x, and both of them are greater than is equal to 0, right? Right. Now I thought of a way that, let rather than finding all the combinations so that values are not equal to these, let's do this. We know what all combinations can be formed, so let's just subtract the combinations that belong in the set, and let's just subtract it with all the possible combinations which are possible. Okay, so what all combinations doesn't belong in set is equal to all combinations minus belong in set combinations, right? So what are all combinations? So all, if let's say there are uh, 5 elements, right, and we need to choose two, then uh, we need to just to pick two every single time. Then how many combinations can you form? Okay, so that is basically c plus 1 into c plus 2 by 2, right? So just a second. nc2, so that is basically n factorial into n minus 2 factorial divided by 2 factorial. So that is n into n minus 1 by 2. Okay, okay, so that is basically c plus 1 into c plus 2 divided by 2 for all combinations. Now we need to just find this value, right? So how many pairs belong in the set? How do we find that? Okay, so I built this these pairs for this particular example just to see and observe some patterns. So let's try to find all the pairs to form 0 by adding. Okay, because we can either add x plus y or we can subtract y minus x, and either of the by doing either of these we need to create these elements, right? Okay, so by adding to create 0, obviously we need 0 comma 0, comma y will be 0 0. Okay, and in how many ways can we create this? By subtracting. And y should be greater than x, so it will be greater than equal to x, so it will be 6 6 5 5 4 4 3 3 2 2 1 1 0 0. Okay, for 3 it will be 0 3 1 2. If we add, we create 3. In how many ways can we subtract and create this? 6 3 5 2 1 3 0 3 0. Okay, so I did this, and then you'll realize that the number of ways in which you can create a 0 or a 3 or a 5 or any value is basically that number divided by 2 plus 1, right? So let's say if it is 5. Okay, so this value decreases, right? The value of y decreases and the value of x increases, right? 5 4 3, it decreases, and this will increase. And in the middle position, it will swap, and the value of x will increase and this will decrease, right? So when will this happen, the swapping, when x becomes greater than y? in in the middle position, right? So that is why we just divide whatever value this is, si by 2. Let's say our set is this s si by 2 plus 1, so we do s by 2 plus 1. So this is the number of pairs we can add x and y and create the particular value si. Okay, what about what about subtraction? In how many ways can we create a particular value si by subtraction? Okay, so we are given c, right? We are given c. So we we have to, so this difference, you know, the difference between y and x has to be this particular value, right? So this can obviously start from c, right? So this will, if let's say this is c, this will be c minus si, right? This will be c minus si, and c minus si, c minus si, and when we go to the bottom, has to be greater than is equal to 0, right? So we start from, so s- and what is the value of c minus sorry x when it is on when it is at the top? It is basically c minus si, right? So when it is on the top, it is c 6 minus 5 si 1, and it will go till 0. So how many values do we have? C minus si plus 1, because this is, because it can at last be 0 as well. So it will start from c minus si. So over here c is 6. So we start from 6 minus si. So 6 minus 3 is 3. We start from 3 and we go till 0. So how many values? C minus si plus 1. So for subtraction, the number of values, the number of pairs we can have to create the value si is c minus si plus 1. So for addition, it is si by 2 plus 1. For subtraction, it is c minus si plus 1. Okay. So we can just calculate this in order of 1, right? Order of 1, and we just loop through this, and we can calculate it in order of n for every single one of them. Okay. But then you realize one thing. What do we realize? We realize that there are a lot of values which overlap, right? 0 comma 0 0 comma 0 0 comma 3 0 comma 3 1 comma 4 1 comma 4, right? 3 comma 3 3 comma 3, these values overlap. So you'll realize one thing, that all the values which are with 0 will always be in pair, right? 0 comma 3 can create 3, but if you just subtract, if you, it doesn't matter whether you add it or subtract. If you add it, it will create this. If you subtract it, it'll create 3, right? So obviously, whatever value we have after adding this and this, we need to subtract minus n, because 0 comma whatever will be 2 times available in the number of, all number of pairs, right? Because it will be in this one addition as well and in subtraction as well. So we just subtract n, and then these values are gone. These values are gone. Okay, so one pair is gone, so we have this. But what to do regarding these values which are common in two different numbers? 3 comma 3 in 0 if we subtract it, and 3 comma 3 if we add it, right? 1 comma 4, if we subtract it we get 3. 1 comma 4, if we add it we get 5. So let's do one simple calculation. Let's say x plus y is equal to si s1, okay, and y minus x is equal to s2, right? So x plus y is giving 6, and x minus y 3 minus 3 is giving some other s2, right? So we need to find how many pairs of this will be created, right? So if we just do this, it will come out to be 2x is equal to, sorry, 2y is equal to s1 plus s2, and if we just subtract it, we'll get 2x is equal to s1 minus s2, right? So you can see that x and y will have to be even, right? X and y will have to be even, because this is even, this is, sorry, this is an integer, this is an integer, and if we divide by 2, whatever we get should be integer, right? So then only we can create, because we are creating pairs of integers. So s1 plus s2 must be even, right? How do we get s1 plus s2 as even? When we add two even numbers or when we add two odd numbers. So basically, how many pairs of even numbers can we create from this, and how many pairs of odd numbers can we create from the set of these numbers? Whatever pairs we can create will be available two times in our set, right? So for example, let's say we have 6 over here and we have 0 over here, right? So if okay, so 6, if we add this 6 plus 0 divided by 2, it is 3, and if we I subtract 6 minus 0 divided by 2, it is 3. So 3 comma 3 will be present twice, 3 3. Okay, but I can't pair it with this or this, because 6 is even and 5 and 3 are odd, so I can't pair it like that. Likewise, if I just pair these two odd numbers, 3 and 5, 5 plus 3 divided by 2 is 4, 5 minus 3 divided by 2 is 1. So 1 comma 4 will be present twice, right? 1 comma 4 is present twice, right? And I can't pair it 3 with 6 or 0 because even odd. I can't pair 5 with 0 or 6 because even odd. So we need to basically find the number of odd pairs and even pairs that exist in this set. How do we find that? That is pretty straightforward. Number of even integers, even integers into number of even integers minus 1 divided by 2, and into n minus 1 divided by 2, right? And we just add this with number of odd integers into number of odd integers minus 1 divided by 2. Whatever value we get, we subtract it over here. Okay, let's say let's call it x. Let's call x the sum of number of even integers, integer pairs, and number of odd pairs. Okay, so this plus this minus n minus x. So this is our complete solution for for this. Now we have to subtract this from this. Okay, so let's just go to the code and see, it will be more clearer. And actually code is much small and cute, just like your instructor. Okay, so we take the input n and c, and this vector is of no use, I don't know why I wrote it. Anyways, we keep int even and odd to keep the count of even and odd, and total is basically c plus 1 into c plus 2 divided by 2. As I told you, c plus 1 into c plus 2 divided by 2 is the total number of pairs that we can create, and we'll have to subtract the number of pairs that create the elements in our set. If we subtract that, we'll have total number of pairs that we cannot create. Okay, so we take the input of the element one by one, and then if a mod 2 is equal to 0, even plus plus, else odd plus plus. And over here I'm okay. So what is this and this? So this is add sum is basically this value, right? We need to create, we need to find the number of pairs uh, which creates this si, right? So that is what is happening. In number of pairs that can create a is a by 2 plus 1, and I just keep adding it for every single element. Number of pairs that can create uh, a is by subtraction is c minus si plus 1. So C minus Si. A is basically Si or Vi plus 1, right? So that is there. And then how many even pairs will there be? Even into even minus 1 divided by 2. How many odd pairs will there be? Odd into odd minus 1 divided by 2. Okay, so this is basically this number of even into number of even minus 1 divided by 2, number of odd into number of odd minus divided by 2. And the total answer will be total minus total number of pairs that we can have to create the values in our set, and that will be add sum plus subsum minus n because 0 creates a pair. 0 will always be in pairs, right? So it will be n pairs for zeros, so that is sorted. And then the number of even pairs and the number of odd pairs, because the number of even pairs will also be twice quantity and number of odd pairs will also be double. So we subtract those and we subtract it from the total, and that is the answer. So that was all the four problems. Thank you so much for joining. I hope this helped you guys a lot. And I'm Utkarsh. I'm a Master's of Science Computer Science student at Illinois Tech in Chicago. And I'm mostly focused towards artificial intelligence and high performance computing right now, getting deep into neural networks and so on. So if you want to follow me, you can follow me through the link in the description. And see you guys around. Take care.